Good afternoon and welcome to Zahn Academy. Today's webinar is how to design a digital denture utilizing the latest innovative 3Shape F8 scanner. Our presenters today are Carl Horrocks, who is the Business Development Manager for 3Shape, and Daniel Alter, who is an MSc, MDT, CDT, and the Professor of Restorative Dentistry at the City University of New York and the Executive Editor of IDT Magazine. Thank you, gentlemen, for joining us today. And here's Carl.
All right, thank you so much, and happy to be with you guys today. So today we got a really great presentation, some live scanning and some live designing. So I think tune in and you'll learn a lot in the next hour. So the first thing, 3Shape, we want to introduce our new F8 scanner. This is the latest scanner that we introduced at Chicago Lab Day several weeks ago, and we're currently shipping to new customers. So first, just who 3Shape is. So 3Shape, we manufacture and develop hardware, so 3D scanners, whether it's intraoral scanners used at the clinical level or desktop scanners used at the lab level, which we'll be going over today. So 3Shape, we develop lab scanners for data acquisition and design software for a variety of different indications. So full denture designs, crown and bridge designs, surgical guide designs, clear aligner designs, you name it, 3Shape has software in the dental lab industry to design it. So today we're going to focus on this part of the presentation with scanning. And we'd like to introduce our newest scanner to the 3Shape lab portfolio, the F8 scanner. This is the next generation of dual model scanning. So several years ago, 3Shape introduced a dual model scanner called the D2000. That was in 2015. And several years later, we introduced a new series of scanners called the E-series scanners. And the E-series scanners were an open-bodied scanner, allowing for full articulator scanning and bite capture. And it was well received by the market. So going forward, 3Shape's always pushing in the lab space to advance technology and give our customers the latest and greatest. We took the D2000 dual model scanning and the latest E-scanner series, open-bodied design, and combined them for our latest dual model open-bodied lab scanner. And things we took a look at to how do we improve from the portfolio that we had previously with this new portfolio of scanners, specifically with the F8. And we really took a look at producing more efficiency. The user is the one who's working with the scanner, and we wanted to make it more versatile and faster. But with speed, we looked at full workflows, right? Start to finish. How long does it take to enter a case to how long does it take to get into that design? And we really feel like with the F8, we're limiting your touch points with the scanner, adding a lot of automation, and speeding up that workflow from order entry to getting your digital case into the design software. Taking a look at the 4 scanners in 3Shape's lab portfolio, we have the E2 scanner, great entry-level scanner. E3 scanner and E4 scanner, which have been our best-selling and most popular scanners in the last several years, and then our new F8 scanner. So here you can see the different speeds between the models, the accuracies of the scanners. But one thing you might see in common if you look down in the bottom is our new warranty and replacement service. So with 3Shape, if you buy a scanner and you enroll your license into our lab care program, it includes our 5-year warranty on all hardware of these 4 scanners. And if anything happens to go wrong within those 5 years, perhaps the scanner is not working, unfortunately, you could create a support case with the Zahn team, and they work with the 3Shape support team, and they do determine that there's something wrong. We replace it. No more repairs needed, no more loaners in case it's your only scanner. 3Shape, we are backing all of our hardware with a 5-year warranty and replacement service. I just wanted to make sure you're all aware of what, 3Shape, we're backing our product with this great warranty service. So let's take a quick look at what's inside the box. what comes with the scanner. The F8 comes with a variety of new accessories that help you with your digital workflow. We have a new articulator holder to scan a full articulated case in the vertical position, so we'll eliminate an extra step in the bite scanning process. And we also are including a new vertical triple tray holder. This allows you to scan triple tray impressions much faster and easier, and eliminate a lot of user instability with flipping the impression over with the older model scanners. So hopefully with some of these new accessories that are included, we'll give you guys a streamlined workflow for scanning bites with articulators and scanning triple tray impressions. And here's a closer look at both of these new accessories. So here you can see a vertical physical articulator. The holder snaps right into the scanner, very smooth and clean. And then to the right, you see our new vertical triple tray holder. So it scans the prep side first. No need to take the accessory out. The scanner will spin the accessory around to scan the antagonist side, and then the software will align the bite automatically for you. Another smooth workflow when it comes to scanning triple tray impressions. Now, being that this is full denture focus, we want to take a look at some of the new features that have been implemented in the full denture software and what users around the world are using our removable software for. So taking a look at what was designed last year within 3Shape. So a little more than 4 million removable cases were designed within 3Shape last year. And there was a big growth from the year previous. And the reasons for this are, one, 3Shape. We're investing and pushing the technology for scanning and designing of removable type indications. But a lot also has to do with the material business and the manufacturing processes, right? We have mill times, new mill materials. Mill times have come down. Printers. We have a vast variety of different printers on the market with new materials coming out monthly, it seems. So the advances in materials, the speed and the accuracy of the manufacturing of these restorations have really caught up to the design side, putting all these powerful tools in you, the technician's hands, to design, create, manufacture, these removable type cases. So that's why we see a big jump from years previous with RPDs, custom trays, which must be the easiest removable indication to design, and then full dentures, what we're taking a look at today. So let's take a look at some of the highlights over the years, which our full denture program has upgraded since last year. So one, we can do dentures on implants now. We have a really smooth workflow when it comes to copying an existing denture. So if you design an existing denture or you're designing a new case for try-in, in 3Shape, you're able to copy that very easy and smoothly for your final or for the duplication of an existing denture. We have some new tools in the Smile Composer. This will help you set cases up quicker with more flexibility for the different types of occlusal schemes that are needed. We have some new viewing windows to help with those types of setups and to help the new tools that are also available in the latest upgrade. And then some customization. You, the user, have special templates that you can set up in the control panel for customizing different gingiva features and characteristic points as well. Other resources for continuous education. 3Shape, we work with some industry leaders, both on the lab and clinical side, because we're both in this together when it comes to digitalizing removal of cases. So here we have Eric Akucha, who's a denturist, and he recently wrote an ebook on how to do dentures digitally. This is start to finish with a lot of the design features. And then on the clinical level, this is always great to share with your clinicians who are looking to go digital into the removable categories, how to also do dentures digitally, but more for on the clinical side of a edentulous scanning. So again, these two ebooks are on our website to download, or you can take a shot of the barcode down at the bottom of the presentation. So with 3Shape, we're really pushing forward within 2023 and beyond with our latest F8 scanner, some new software to help manage cases, some new model maker modules that are coming out. So we're really pushing hard within the lab space to make it easier and more efficient for you all to digitize your cases and design them. All right, so now we are going to move over to do some live scanning. So I have a couple webinar cams set up. So first, we see our dental manager. This is where we're going to see the cases that we've already scanned in. You know, if the cases are designed, we can tell where they are in the design and manufacturing side. But this is where we're going to come in and we're going to do the first step of our denture case, which is order form creation. All right, so we're going to fill out our order form. And for today's scan, we're going to do a full over full denture. And I'm going to highlight the teeth that are associated with this full over full. We're going to click on artificial tooth or denture teeth. We're going to click on our gingiva. We want some gingiva on our base denture. And then we're going to bridge them together. So it'll be all one piece tooth file and then our base gingiva file. We're going to do a model scan. And I think we're good with this basic order form fill out. So now we're going to hit scan. So this is going to create our order and it's going to bring us into the scan software. And since we're scanning with the F8, this might be a little new for some of you. So within our scan software, we are going to follow the directions very closely. And on the left-hand side here, we see what the scanner is asking for. So it's asking for my prep arch on the inside, which is labeled position number 2. There's 2 stripes on position number 2. And then it's going to need our lower arch on the first position, position number 1, with the 1 stripe. So to see that, we're going to switch over and I'm going to show you the inside of the camera and the scanner. We got our F8 here. So we have our upper model set up on our height adapter. We're going to snap that into the scanner with the magnets. And then we have our lower arch on the 1 stripe. You can see the 1 stripe here on the scanner. And we're going to fit that in. Now there is an auto start function, but I turned that off for the webinars. I didn't want to get my hand stuck in the scanner, but I was still talking. So we're going to use the mouse and we're going to hit scan. And now you'll see the F8 in action. You'll see it might be hard in the back, but there's 27 lines of blue LED light that shine down onto the model, and it'll rotate around to capture all of that data. Now, being a new scanner, 3Shape, it's a little bit different than you're used to. We have this light and camera bar that rotates around the model or the impression, if we were scanning impressions, while the base plate spins to rotate the model around in view. And then now it's finished scanning. It's post-processing. And now it's going to ask us to scan the wax rim. That's part of the process of scanning a denture case. We need the wax rim for the bite. And in this case, I have a denture for my wax rim. And we place that in the scanner. And we're going to hit scan. And now we're going to scan our occlusion with our existing denture being our bite scan. This is going to help several ways with design in the future. Just help with setup, help with alignment. But again, this could be a wax rim with any sort of scores to help with alignment. Now, that would be the scanning. We are done, but we have to do some alignment. So I'm going to switch over to Dental Manager webcam, the design software, and here we have our bite scan. And the reason why there needs to be some alignment is because we scan an edentulous upper and edentulous lower, and then the bite. And there aren't too many like spots for the software to align it. So we're going to have to do this ourselves. So we just come down and we're going to pick 3 corresponding points. Oops, doing the lower arch, meant to do. We're going to pick 3 corresponding points on our model of the bite scan, and then our model of the edentulous scan. All right, we see that aligns for the lower. That's great. Now we're going to do the same thing for our upper arch. We're going to do 3 like points. Now again, we've come out with a lot of improvements with bite alignment, but that's when you have a lot of like spots on your model scan and your bite scan. Being that this is edentulous and then a full wax rim scan, it's really hard for the software to make the alignment. So for this one type of indication, we are going to need to align this manually. But what we're going to do is we're going to tell the software to keep this bite scan, so our wax rim scan, which is this denture case. We want to keep all this information so when we go into design, it's there to help with setup. But for the most part, that would be the workflow of scan, order input, scan, and then alignment to get our case into the denture design software. So I hope we learned a little bit about the new latest F8 scanner, a little bit about the denture software and some of the new features, and then switched over to some live scan when it comes to order entry on the denture case, and then following the steps on screen, working with the F8 scanner to acquire a denture case fast and efficiently. So I'm going to hand it over to Daniel, who will then pick up the presentation and take it from here.
Awesome. Thank you so much, Carl. Really a great presentation, and the F8 is absolutely a remarkable scanner that allows us as a laboratory to be able to, scan, design, and fabricate efficiently and certainly seamlessly. So with that said, I'm going to be doing a live design of a digital denture. Now, what I'm going to utilize is the Dentsply Lucitone digital, both the library as well as the denture base. So for us here, and I'll show you, this is the scan setup or the order form rather that I'll be designing. I've already imported a slightly different dual arch, in order to. What I've done is though I've utilized a wax bite rather than a denture, and Carl showed how to utilize a denture, which is a great workflow and a great process. But there are many times that we get a wax bite or wax rim rather. So that's what I'll be demonstrating. Now, the other difference is not only am I utilizing, as you see here, the Lucitone library of teeth. Now, when it comes to the Sirona library of teeth or the Lucitone library of teeth, this is something that once you purchase or engage with being able to design these digital dentures, you're able to Dentsply then offers you all their molds and their teeth in a digitized form. So you can approach this from multiple different ways. Certainly, you can use their carded teeth, which is a slightly different workflow than what I'm going to be demonstrating. You can use their library and their molded teeth, which is what dentists are accustomed to, and nothing really changes for them. It's just the fabrication process by which we as the laboratory fabricate these digital dentures that's different. So as far as the material, they're accustomed to obviously a Lucitone They're accustomed to the type of molds and the sizes and so on and so forth. So it makes it really, really very easy to incorporate digital dentures in with less of a hesitation, because it's what they've been accustomed, it's what they've been utilizing for many, many years, and what they continue to utilize. And there's a sense of confidence and assurance in that. So that's what I'll be demonstrating as well. The other thing that I typically like to do is not only select the teeth, but when I'm selecting the gingiva, I like to bridge. You can certainly bridge the entire arch, which many laboratories do with great success. I like to bridge them a little bit separately, only because when it comes to the post-processing and bonding the teeth to the denture base, I find that it makes it a little bit easier with the path of insertion and being able to bond it without any kind of anything holding it up. Now, I have in the past, if there's a diastema, I may choose to do it in every quadrant and then split up the 6 anteriors into 2-3 unit sections. So it's really at your versatility and what it is that you want to accomplish and how you see the post-processing to be done. You can certainly do the full arch, which, as I said, a lot of laboratories do with great success. I just prefer to break it up into quadrants, as you see here. Now, you select the teeth that are going to be involved in the denture, and then, as Carl demonstrated, you select artificial teeth. And then when you go into the materials, you want to make sure that you select the appropriate tooth mold, or the appropriate, rather not mold, but the appropriate library that you'll be using. Then when you get into the gingiva, same thing applies, where you get you click on the gingiva, but then make sure that you go into your materials to make sure that it is the digital print 3D printing. Now, again, when we're doing this, and I'll show you the nuances, this case is set up as a 3D printing platform, but you can certainly choose in your laboratory whether you want to mill the teeth and then print the denture base, mill both, print both. It's really at your discretion, which is what I love not only about 3Shape, but also about using this workflow, because you're able to, it's not a cookie cutter. You're able to make choices and design and output whichever way you see best fit. So with having that said, we're doing both the upper and the lower arches. So I'm going to go ahead and click on OK, which I've already imported my models in there already. So I'm going to go straight into design, and I'll show you the entire process all the way through. Now I'm using the 2021 version, but nonetheless the 2022 is a fantastic version as well. So you're able to do that, and this is where you see the first proposal, the first after scanning. So our next step is going to be to align the occlusal plane. And that's just a 3-dot, and obviously when you have a wax bite rim with a more of information, it'll be a little bit easier, but this is the guided plane as you see here. And what you want to do is you want to just establish not only where the wax rim is, but where the teeth are going to be emerging out of. And you'll see what I mean in a second, because you want to align it. The better you align this at this stage, the easier the proposal of the teeth will emerge, and you'll have less adjustments necessary to be done in the design function. So I just to make sure that I want to make sure that my frenum is in the right place and into my midline, so that there's no variations or no differences, and just really manipulate it to where I want it to. So now once I'm in a happy set or where I want it to be, I may want to just move that slightly over a little bit. And then I'm going to go ahead into my characterization points. Now, characterization points, the software really guides you through, and certainly you can expand it if you need be. The one thing that you really want to be mindful of is, as you see here, there's the number 1, number 2. It's really irrespective of which side you choose. I happen, for whatever reason, to always choose the left side as my number 1, but you may choose your right side as your number 1. The criteria is just to make sure that whatever side you choose, just to stay uniform with that. So for example, I'm going to choose my number 1 tuberosity, then my incisal papilla, then my tuberosity number 2. But now I'm going to go to my canine to where it's number 1. So I'm going to make sure that my emergences of the canine of number 1 is correct, and then make sure that those align properly as well. Now I'm going to go over to my mandibular mold and do the very same thing on the left side for whatever reason. And again, there's no rhyme or reason. You can choose the right side whichever your workflow is. So I'm going to use the retromolar pad number 1, then retromolar pad buccal number 1, and then the lingual number 1. Similarly, the central point, then retromolar number 2, then the buccal pad of number 2, and then the lingual, and then the canine point. And if you recall, my left side is where my canine point or my number 1 is. So you want to stay consistent so that it maintains the right all the way through. So once I've annotated or placed my points, I'm going to go ahead into my upper boundary. Now the upper boundary is literally just that. It's the boundary of the denture, and you'll have 2 opportunities to plot this. In this opportunity, and where I like to spend a little bit more time, you're really plotting out where your denture is. Now, I do it rather quickly because I'm going to show you in a second. I can go into my fast line mode and really adjust appropriately. And at this point in time, at this junction, don't be as concerned about undercuts, because I'll show you in a little bit how you're going to block out those undercuts, so they're not really going to affect your overall fit. But you want to place it around the border where the denture will be, in order to make sure that it functions properly and that if it's comfortable for the patient. And you want to go all the way through. And if there are some points that you're just not okay with, or you want to adjust, that's okay. Just keep going all the way through, because once you've complete that complete circle, you can go to any of these handles, right click, and you can do a fast line edit mode, which then allows you to then literally just draw where you want your borders to be, and it will adjust accordingly, so as you can see here. So this, I like to spend a little bit of time here only because it produces better results. You will, and I'll show you during the design function, you'll be able to, yet again, adjust any of this to accommodate exactly what it is that you want to see as an end result. But I like spending a little bit of time here so that the end result or the flow becomes a little bit more seamless and more, intuitive and easy to follow through. So I'm going to just wrap around this area. And then once you do this, we're going to go ahead and we're going to also do the same thing on the mandibular arch. I'm just going to check. This all looks fine. I'm going to go on to now the lower jaw boundary and do very much the same. So again, I don't know if it's out of habit, I always start over the left, but you can certainly, you can go to the right, you can start wherever you'd like. As long as you make a full circle all the way through, then that will become your denture base. And we're gonna go all the way through. And you can see I do this rather quickly, only because I can do the fast line edit mode thereafter, and then be able to adjust if need be. You want to make sure not to get any of the muscles in and engage in those areas to really be able to perform. And then once I complete that circle, we can always go into the fast line edit mode, as you see here, and then draw as you feel. Now I'm using a mouse. You can certainly use a 3D mouse, which makes it a little bit easier to navigate through. There are some stylists that I've seen people do some great success with when coming to this type of function. They're literally able to draw on the screen to get the results that they're looking for. So you have a lot of tools at your disposal to make you successful with digital dentures, which is really an exciting and increasingly growing, market solution in our dental profession. And it's something that's really growing rather rapidly and taking hold. So once I do that, then I can go ahead into my next, which is going to be the, any kind of undercuts. Now, here with the undercuts, there are multiple functions that you can do. Now, certainly this is just to block it out. As a rule of thumb, I like to just look at the axis by which the patient is going to place it in. So you're almost looking at how the denture is going to be placed into the oral environment, because the patient is going to be bringing it in. Now, I always like to also do a block out angle of about 3 degrees, and you'll see what I mean in a second when I transition to the next one. But What it is you don't want it to be too where the, obviously the path of insertion for the way the patient is going to be inserting their denture each and every time, which now I'll go into the next, and you'll see these undercuts here. But being that I clicked on the 3 degrees, and you can control that, you can make it 2 degrees, you can make it 1 degree, whatever it is that, however much you want to block out or not block out, you're within your control. But you still have the ability now to go in with a wax knife, be able to add any areas that you think you may want to block out. As you see here, you may want to reduce any certain blockouts by the border. This is really, just comes back to the fundamentals of denture design, but hopefully what you can see here, it makes it significantly easier to accomplish that with a repeatable and consistent process. So once I've blocked out, then I'm happy. Now I'm going to go on to the mandibular. And I'll do very much the same. And although this is pretty much established in that same path of insertion as the patient would probably do, I will still nonetheless bring it in a little bit more, perhaps reduce this from a 3 degree to a 2 degree, just to show you the differences. I mean, you're not going to see much of a difference, but you'll be able to see that it blocks it out with that angle as well as that. So it blocked it out slightly less, but nonetheless, you can see that it blocks out so that the patient will be comfortable and they won't get any kind of denture sores or anything like that. So again, it gives you the wax knife. What I like about the software is that it really mimics not only the traditional workflow of dentures and now converting it into digital, and thereby creating a less of a learning curve for denture technicians, because it's identical to what we did in the analog world, if you will. Similarly, for crown and bridge folks or fixed folks, it's an easy learning curve yet again for anybody that's proficient or is comfortable with CAD to be able to now utilize or fabricate digital dentures. So it's another opportunity for your laboratory to be able to offer this to your dentist in a great way. So once I do that, if you see, I've opened up my my molds, and certainly there are a lot of molds. As I said, I'm using the portrait teeth, which come up. You'll always want to do. You can either, if you're doing use single posterior, and there's different molds that you can use. Here we're using the full arch libraries, and this came about. The software proposes it from your characterization points where we've selected before, where the tuberosities are, where the incisal and in the the central line is. You can change it certainly as you need, and you can even change it from a balanced to a lingualized. So here you see this is the lingualized as well in the same mold 11H, and you can then go ahead and change it into balance. I do, depending on the shape, the case and what the dentist wanted, you can change the molds. But for this case, I'm going to leave it as a balanced with the right appropriate. Once you press on to apply, it will propose those teeth for you. And again, the better you've done your alignment in the previous from where the scan is, the better this tooth will propose, because it utilizes your alignment as you see here. Now, if you need, you can always bring in your wax try-in. But I'm going to go ahead now and start moving things around in order to get the design. So keep in mind, this is the original molds from Dentsply, from the Lucitone, but you can now manipulate it in a digital form, and I'll show you what I mean. So I'm going to first move this a little bit just away from the ridge, because you do need about 2 millimeters away from the actual the ridge, as you'll see. You can move this as a whole, or you can move individual teeth, and I'll show you how I do that, how I do both. You can move both arches, which I really like, because now I can even bring this down or up as a whole. Now, keep in mind that these DMEs and these libraries are set up in such a way that they will be an occlusion, but I'll show you how you can still nonetheless move it and have it to where it's going to create that perfect occlusion in a great way. So aesthetically, I'm going to go ahead and I'm going to move into now global transformation. I do like to keep the symmetry design as you see here, because when I make any kind of movement on this lateral, the same will apply on the lateral next. So I can move this along. I can twist it as you see here. or distalize it slightly. And I can do the same thing with the cuspid. I like to bring that over slightly and then just have a slight distalized tint. Here, I can again move it over, bring it into proximal, bring it into proximal. Now, even if it's for some reason you're worried about the occlusion, which is okay, I'll show you how quickly and easily you can make those changes in this design. So you have, the full versatility as you would with carded teeth, placing it in. So once I've made my adjustments, I can go tooth by tooth. I can right click and I can say, bring this to the mirror image, and you'll see the teeth actually moving individually. I'll do the same thing on each tooth and bringing it to mesially. So this now gives us the proper orientation of the proper contact, and the green line is where the gingiva or the denture base is going to be attaching to. So I'll move that over. So any of my adjustments are no longer of consequences if they're out of line, as you see here. When you get to the posterior, you want to do two things. You want to bring to mesial contact, but you also want to bring to contact with antagonist. So if you've made any changes that are going to interfere with the contact or with the occlusion, it will automatically adjust for you, and we'll be able to do that as well. And then I'm going to bring this to the mesial, and I typically do this only on the maxillary arch because the mandibular, unless you've made any kind of movements in the mandibular, then you can certainly do the same. It's just a balancing or a equilibrating, if you will, of being able to accomplish that. So I'm gonna just make sure that my occlusion is good. I like to double check and triple check just to make sure that I have it on both arches. Again, it takes two seconds to do, and if you're not talking, it takes a lot quicker. So we're able to accomplish that rather simply and easily all the way through. I'm just gonna do this now too as well, because if you remember, being that I did the symmetry, whatever I've done on one, I did on the other. So I just want to make sure and be mindful of my occlusion, because the less adjusting after it is printed or after it is done, then it makes it a lot easier to then post-process and finish. And the idea is, when you're doing these type of cases, is that you really, really want to be able to just out of the printer, and I've actually, we've done several of these already, and it's really seamless and very easy to do. That you can actually take it right out of the printer, and you can print rather quickly. You can scale this in a great way, and you can print them. And the more work you do a little bit in the design, the faster and easier and less adjusting, if any, needs to be done in the other portion. So I'm going to go ahead now and establish my maxillary base. That's okay. And so now it's going to take, if you recall, it's going to take my block out as well. Now there are three choices here that there's the delicate, and again, it really is respective of your laboratory and what your dentist clients are expecting from your laboratory. So meet their expectations, see what the artist or the aesthetic value that they're looking for. You can have either the delicate, you can have the natural, which is the one I'm going to select. You can also select a very intense one as well as a custom one if should you desire. Now up here is, you'll see this is again where the border is, so you can certainly make changes again to the base plate or the denture base rather, as you see fit. You can make changes to the actual handles, you can make changes by fast line edit mode, but what you want to do is you want to make sure that it doesn't engage into any kind of undercuts or anything that may prevent the denture from seating comfortably for the patient all the way through into the muscle. And you can see here that it's already blocked it out, so we are less concerned with that area. And finally, you can always, now here, if you were to, depending on what it is that you're doing, if you're doing the denture base, and if you're going to be milling it, then you want to make sure to click on this, which is going to give you the drill compensation, which again relates to whatever the smallest burr that you have in the milling machine. That's going to accommodate and make different parameters for that denture base. But being that we're printing it, you just want to make sure that we unclick it. At any point in time, you can go ahead and you can select the preview, which is going to then propose for you what it looks like. We'll still have the opportunity to make adjustments, but just so you're able to see what the natural look is I just wanted to preview it, and then we'll do the very same for the mandibular. Just it takes a little bit of time to kind of process it through, but you'll see I'll snap right onto these where the green lines are, the CEJs of the natural teeth are. You'll see in a little bit once we go into the next stage, it's going to have a lot to do with assembly and making sure that it has that process all the way through. And we're at 88%, so it should be coming up soon. And that provides you with, and that's the natural look. So certainly we can enhance upon it, and we will. But depending on the quality of the dental laboratory and quality of the production and the aesthetic value and whatever have you that your dentists have grown to expect from your laboratory, very much the same still applies. Nothing changes, nothing should. Again, digital is an incredible instrument, but in reality, it is just a tool in order to allow us to be able to produce very much efficiently, seamlessly, and a superior product because it's repeatable and consistent, but the level of aesthetics, the level of quality should remain the same as to what your laboratory does or accomplishes on a regular basis. So I'm going to just make those adjustments. Again, I'm going to select natural. I'm not going to be milling this, so I don't need to select this. Any changes you can still make. You can even do a window here. I mean, obviously not on the mandible, but if you wanted to do a window on the maxillary, you can certainly do that in this function. But we'll go ahead and we'll see what that looks like now once we preview. So, you know, as I said earlier, CAD/CAM is really just a very incredible complex tool that allows us to really do things that geometries and things that perhaps we weren't able to accomplish before, that we can do this now in a very repeatable and consistent way. It offers us versatility, it offers us efficiency, and certainly scalability to be able to produce that in a shortened time than what it does in traditional and in analog format. But a lot of the dental IQ that we know is what works and what is viable in the mouth should remain very much the same and should not change. So here now we're doing the connectors. So the connectors, if you recall, are going to be the quadrants, which are going to be, so I'm going to go ahead and you can set these depending on what it is. You know, if you take a look, if you hover your mouse over it, it'll identify or explain what each one of these functions are. So the facial scale, as you can see, 100% of it is really the connector, where 80% of it is what you can manipulate. The lingual scale, again, is how far from the facial aspect to the connectors, lingual, and the center scale is, again, between the facial aspect to the lingual aspect. I leave this on the default. And what you'll see is now you're going to have connectors here, where before it was individual teeth. I'll do the same. There are times that I do lower this to a 70, only for the anteriors only, because I find that it's, you know, oftentimes it creates a slightly lesser of a connector there. So it doesn't protrude out as much, but still is a solid connector all the way through. Then on the posterior, I'm going to leave the way it is. I'm going to then go ahead into the mandibular. Oh, before I do that, I'm going to sculpt onto the anatomy. So in the anatomy, certainly you can do the morphing tool, and you can utilize the QWERTY, which is the QW. So I'm utilizing my tools all the way through to be able to add, if you will, to the teeth or the anatomy itself. I'm going to reserve at this point to do my denture base. And so it gravitates through. So you're still able to manipulate or change things tooth-wise. But for us, I'm gonna use my morphing tool just to increase slightly the gingiva in certain areas, which you can certainly do. You can leave as B, but also you can do this as you see here, where I can distalize, if you will, the lateral slightly. You can really characterize this whichever way you prefer to, again, reap the results that you're looking for. Nothing should change as far as quality and aesthetics just because you're utilizing a different tool or a sophisticated tool like CAD/CAM. So very much of the same as far as the dental IQ should stay through and through. I'm going to leave that alone. Then I'm going to go ahead and if you need and if you want, you can certainly add some more of the root prominence. You can add a little bit. And sometimes, you know, the imperfections is where you get the most natural look. So I know you can spend a lot of time adding some of the root prominence, but you can also, you know, leave it be. So one other thing that I like to do is oftentimes if there's rugae, I can then go ahead and just ghost the denture a little bit. And now I have this plentiful information from the actual patient as to what the rugae looks like in their natural mouth. So I'm just reproducing it into my denture base. So this is a quick and easy way of really creating rugae that the patient is very comfortable with and can utilize. And it's just, as you can see, it's significantly easier to do or accomplish, and it's just something that the patient is comfortable with. Now I'm going to go ahead and I'm going to move on to my coupling. Now the coupling is where you're going to be, it's going to be setting it, and oftentimes what I'm looking for is, again, the path of insertion, which is a degree which is going to be connected. Here you can still nonetheless change it if you want to, the radius and so on, but I typically leave it as the default, which makes it easier. Here you can see again, the anterior is doing that. So for time's sake, I'm going to move rather quickly through this, and then because I want to show you the output once we're done. Because a nice thing with the Dentsply Lucitone is that you do get, when we're completed with this, you get multiple files. Not only do you get the again, if you're going ahead and you're going to be milling it, make sure you hit the drill compensation, but otherwise it gives the minimum thickness under the teeth. And so again, we set this up all up as we're going to be 3D printing the denture base. We're going to be 3D printing the actual teeth, which you can select to do one or the other, 3D printing or milling or whatever have you. It's up to you and your workflow and your protocol to be able to, you know, what is the output that you're looking for. Here you can see where this quadrant is connected now, because it does have the individual. This process takes a little bit of time because you're seeing that it's the different blocks. So as I was saying earlier, with Dentsply, a bonus that you get when you're designing this is that you're getting the complete monolithic kind of a denture, and you're also getting a denture base and individual files for the teeth that you can mill and separate. So depending on the workflow of the dentist or what the dentist is comfortable with, if they want to try in, you can do with one effort, one design, have them try it in, produce that one STL, which I'll show you at the end of this design, where it's a complete monochromatic kind of denture so that they can make their adjustments or whatever have you. However, you can also produce the denture base as well as the teeth, as you see here, where you can produce it. Now, with that said, unless the dentist absolutely is adamant about trying in, 90% of the time I do prefer to try in the finalized denture, as you see here, because in my mind, if we're doing the finalized denture and 90% of the time it works, then we save the dentist an additional step, as well as you know, for us in the laboratory to produce again. If there's any kind of adjustments that are necessary, which may occur, the dentist can go ahead and scan that. We can then re-import it into our design and then be able to make those changes to accommodate his adjustments and reprint or re-mill or whatever it is that needs to be done. So it's a workflow that really, really works in a great way, but it's really up to what your dentist and what your laboratory can produce and what the end result is. Now, it's taking a little bit longer than I'd like with processing, so hopefully all is good and we'll be able to proceed. So what it's actually doing right now is setting up the sockets, if you will, for the denture base. And with each section, because again, we're doing a 2 millimeter socket for each one, slightly divergent, so that the fit or the post-process thereafter will be easier for the post-processing to be done. It makes it a lot easier because you don't necessarily need a you know, a seasoned denture person to place it together, because it truly fits in like I don't want to say a puzzle, but it fits in like a glove. very easily, and it's not, it's not difficult to put it together, and the chances of it being a little bit, out of whack, or the tooth may be slightly off is less and less because of the way the manufacturing is being processed, or the pre-manufacturing right now. So once it's completed, I'll be able to show you what those steps are, but for the sake of time, I just want to move forward once it completes, because we still have to do the mandibular in the same process. So right now it's cutting the gingiva in order to accommodate it all the way through. And just bear with me, I apologize, it's taking a little bit longer, but it's processing. And this is an important step that you just, you want to make sure that you pre-manufacture and the assembly is proper in the coupling mechanism, which will make your lives significantly easier. So now we're going to go ahead and we're going to do the same thing, but I'll kind of blow through this just for the sake of time without any kind of adjustments. You can make obviously adjustments as I've shown you on the maxillary arch, but in order for, because of time, I just want to get through it so that you can see the finalized process. Now again, you can make changes to the teeth here, or the design, or the library, if you will, then to the actual denture base. So you just click that off. And then the coupling mechanism, very much like we did, I'm looking for more anteriorized coupling. And once we do the pre-manufacturing, it'll go into being able to save. And then what I want to do is I want to show you what kind of cam output you receive as an STL. So again, we're going to leave all this be. The only thing is that you need is, if you are utilizing a mill, just make sure you do click on that drill radius and drill compensation. So now it's taking, again, it's figuring out from the green line to the denture base how much room it needs to cut and the divergence so that it all fits in. You can see that your teeth are solidly connected, as we see there. And you can go all the way through, and hopefully this takes a little bit quicker than what the previous one did. But nonetheless, it takes about a minute and a half. There's a lot of computation that it needs to do, but it's all for good reasons, so that it makes the post-processing significantly easier for us to be able to fabricate and be able to finish. So what you end up getting here is not only the teeth blocks, as you see here, the 17 through 14, 13 through 23. So these are all the segments, as well as the gingiva. We're going to have two denture base, because it's an upper and lower arch. So it's really if you're a denture technician that's looking to digitize, this is a phenomenal process, phenomenal workflow. And again, the best part about it is it's repeatable, consistent, and you can have this be able to scale. So your expertise as a denture technician can really scale, where you can produce more with the same level of quality, dental intelligence and function all the way through. If you are a fixed technician that wanted to get into the removable, which is removable is one of the largest growing segments currently in our dental profession, or in the market. So it's certainly an opportunity for some of the fixed laboratories that want to engage in that. Hopefully you can see I myself am a fixed technician, for lack of better terms, although us dental technicians are restoring the human oral environment. So regardless if it's fixed or removable, nonetheless, hopefully you can see that it is significantly easier to be able to do this and accomplish this in a very efficient and great process way. So it's calculating. And the next step will be to actually save the double arch, or the the set of dentures, and that is your denture. And you see that it's being saved at the moment as we speak. And this is it's still processing. This becomes now your upper and lower your denture that you can absolutely do. But what I want to do is, first I want to be able to close this, and now I'm going to show you what kind of output it puts out, which is really unique and interesting, because again, depending on the type of process or the type of workflow you and your dentists have agreed upon or that want, you can cam either as segments, which I'll show you in a second, or as a complete mono kind of thing. So I'm going to go ahead and I'm going to click on all these. These are all the STL files that were produced from our design just now. You can see the teeth. Now, if I can only identify which ones are which, but so these are your teeth and their segments. That is your, so these are the sockets, as you can see here, that your teeth are going to be. You can then go ahead and create. So that's what's going to put out, where you can either mill the denture base or you can do the individual teeth, as you see here. And these are the sockets that fit. It really, it's rather remarkable of how well it fits. And let me just show you the. And this is the other. So as I shown you the teeth, it also produces an STL file, as you see here, where it's one monolithic. So you can print this out of all tooth color, have it as a try-in, and this is like that bonus, like I said earlier, that you can absolutely do, where it's a you're able to produce a either in this way, or you can produce a full try-in as this, depending on what the dentist wants to do. My preference is to go to the definitive denture because I can make those adjustments, but if the dentist is absolutely adamant and wants to try in, nonetheless, it gives you that STL file that you can produce, you know, a try-in out of all one tooth color. And if the dentist makes any kind of adjustments or any kind of things, you can certainly accommodate for that as well. So hopefully this was helpful. I really appreciate everybody's time, and my apologies if it took a little bit longer, but nonetheless, happy to share it and enjoy digital dentures.
Thank you so much, Dan, and thank you so much, Carl, for your information for our attendees. And I want to thank all of our attendees for joining us today on Zahn Academy. I hope everybody has a great day, and we'll see you next week. Thank you.